In this segment, I will demonstrate how to make slip for casting gas diffusion bulbs. I learned how to do this from watching YouTube videos. To let you know how ironic this is, I must tell you that I have a PhD in ceramic science. Slip casting as a scientific endeavor is tucked away in one of those chapters at the end of undergraduate textbooks that typically gets skipped. I spent my 40-year career making advanced ceramics from exotic and very costly materials. Slip casting was not a process that we generally considered for making these advanced ceramics. So I stumbled into clay-based slip casting in retirement completely by accident, mainly because working with clay is easy and inexpensive. I was inspired by this exquisite vase made around 1910 by renowned potter John Harold. He slip cast it from clays that exist in the foothills of the Rocky Mountains in the vicinity of my home in Golden, Colorado. I never dreamed that delving into the area of art pottery as a hobby would lead to fabricating very advanced porous supports for such things as hydrogen separation membranes and catalytic microchannel reactors. Devices that will enable almost anyone on the planet to make their own hydrogen one day. The slip I will be preparing is composed of 95 weight % Edgar plastic kaolin from a quarry in Florida and 5% silica to give the fired parts a little more strength. I call this formulation EPK+. There are hundreds of clays in abundance around the world that might work just as well or better. EPK Plus is the result of only about a dozen of the 100 factorial possibilities, but it seems to work well in my application. The slip is prepared in a BlendJet smoothie maker, available from Amazon or almost any home goods store. It is ideal for making small batches of about half a liter, enough to make a couple dozen bulbs. The formulation calls for 200 grams of deionized water, 380 grams of EPK, and 20 grams of finely ground silica. 5 milliliters of Darvan 7, a sodium silicate deflocculant, is added to thin the slip. The ingredients have been pre-weighed for this demonstration. You might be wondering how I am going to fit all this powder into the blender. It's magic. First, I will add the silica powder to the deionized water in the blender. Then, I add about 200 grams of EPK. Shake the BlendJet to disperse the powders, followed by a 20-second blend cycle. And more shaking is necessary. Opening the lid, you will see that the slip has about the consistency of yogurt. This is because the clay particles strongly attract one another. I need to add the Darvan 7 at this point as a deflocculant, which neutralizes the electrostatic charge on the particles, making them electroneutral. After closing the BlendJet and doing another blending cycle, the effect is magical. The consistency is like chocolate milk. I use a rubber spatula to scrape any clumps from the sides and lid, then start adding as much of the remaining EPK as will fit. I seal the lid tightly and repeat the blending and shaking with scraping and blending cycles as many times as required until all the EPK powder has been added. The final consistency, when all the powder is dispersed, should look like heavy cream. I transfer the slip to a 1-liter Nalgene bottle that has been tared on the balance to confirm the total weight of the ingredients. I scrape the remaining slip from the sides of the blender and check for any undispersed powder. If the ingredients don't weigh within a few grams of 600 grams, then I know I did something wrong. The final and most important step is to label the batch with the ingredients and date prepared. Casting slip can get old and multiple batches tend to accumulate around the shop, so it's a good idea to keep track of what's in the bottles. The new batch of slip needs to age for about 24 hours, so I will clean up now and return tomorrow to finish up. Okay, the slip I made yesterday has had a chance to age a bit, and it's time to see what we've got. The first thing to do with a new batch of slip is to peek in to see if a skin or crust has formed on the surface. This is an indication of overflocculation. This slip looks good, so I will proceed to measure the specific gravity. Specific gravity is simply the weight of 1 cubic centimeter of liquid. Many potters use an instrument called a hydrometer, but for these small batches, I have found it more convenient just to weigh a known volume of slip directly. For this, I will use a 60 cc syringe, filling it first and ejecting the contents and tearing it on the scale. Then I fill the syringe again and adjust the plunger to the 50 cc mark. The weight times 2 and divided by 100 gives the specific gravity in grams per cubic centimeter. I'm weighing 83.65 grams, which gives a specific gravity of 1.673, just about right for a 7-minute cast time for the bulbs I will be casting in a while. After transferring the slip back into the Nalgene bottle, I will use some of the slip left in the syringe to cast 4 discs for measuring the drying shrinkage and confirm that it dries without cracking or sticking to the plaster molds. Hopefully this video demonstrates how easy it is to make small batches of slip. I learned how to do this in my kitchen. I never needed any of the fancy laboratory equipment I was accustomed to during my corporate career as a research scientist. Perhaps this video will inspire thousands of people to experiment with making slip or slip casting ceramics for gas diffusion bulbs, or the myriad of other potential applications that will surely come to mind.